at us human beings might be walking, what you're doing is you're not really using muscle to lift your leg and you like to walk like a robot, right? What you're doing is you really swing your leg and catch the ball, stand up and swing your leg and catch the ball. Using your built-in dynamic physics of your body, just like a pendulum. We call that the concept of passive dynamic motion. What you're doing is when you stand up, potential energy, kinetic energy, potential energy, kinetic energy. And it's a constant falling problem. So even though there's nothing in nature that looks like this, really we're inspired by biology and applying the principles of walking. This robot does is a biologically inspired robot. What you see over here, this is what we want to do next. We want to hold up the legs and shoot it up for long range motion, and then deploy his legs and lose all of himself or swing flags and absorb the shock and starts walking. What you see over here, this yellow thing, this is not a death ray. This is just to show you that if you have cameras and this type of sensor, because it is called 12.8 as well, you can see over all the This robot is a very recent project called the Raphael, robotic air-powered hand with plastic wings. There are a lot of really very good robotic hands out there in the market. The problem is they're just too expensive, some thousands of dollars. So for cost that it's probably not practical because it's not affordable. We want to go tackle this problem in a very different direction. Instead of using electrical motors, electromechanical actuators, we're using compressed air. We know these novel actuators in place. My expert can actually change the force simply with changing the air pressure and can actually crush them and sort of can become very delicate objects like a raw egg or in this case a light bulb. The best part is it's only $200. This robot is actually a family of snake robots that we call hydras. Hydras are robotic artificial certified. This is a robot that can climb structures. This is a hydra's arm. It's a little bit of robotic arm, but the cool part is the user interface. The cable over there, that's an optical fiber, and this is the part the first time using it, but you can articulate it in many different ways. So, for example, in your horizontal, there's a roadside box. These things, remote controls cable in our arm. It takes really a lot of time and expensive to train the operator to operate this complex arm. In this case, it's very intuitive. This student, probably first time using it, very complex activated test, you all objects and the imagination, just like that. Very intuitive.
Isn't it amazing? At the original video, it was 60 minutes long, so I edited the video. At the original video, he mentioned about the reason why they could be so creative. So, if you want to know more about these things, search Dennis Hong at TED homepage. Second video is about cheetah-inspired robot. It was made by Sang-baek Kim. He is the graduating senior of Yonsei University. Now he's an MIT professor and runs the biomimetic robotic lab. Let's see the second video.
I'm not trying to replicate biological systems. I'm interested in their function. When I watch the cheetah run, I can see a lot of details. I can see the muscle getting tense, and then in the swamp, you can see the paws flicking and then birds flying. I can see energy exploding from this biological machine. That's really fascinating. We can study why the cheetah is the fastest landed, and we can expect the design principle. Those principles we can actually implement in lives. Here at MIT, we aim to achieve a fast, agile, and energy-efficient robotic cheetah that can be used in the field. My first thought is to minimize leg inertia by shifting masses close to the body. This will help increase the leg speed and minimize the impact losses. For the MIT cheetah, we developed a new actuation paradigm that allows high forces and programmable compliance at the same time. This was possible by going back to fundamentals. We studied the geometric principles of electrical motors and redesigned them for our specific needs. This actuation technology allowed the robot to reach high speed and energy efficiency spread
far, we saw some amazing robots. To make these things, creativity is the most important ability. To become a creative design engineer, students are recommended to take classes named Creative Design in our Yonsei University Mechanical Engineering. I will introduce two projects that were performed in creative design classes. First one is what I have done last year. The evaluation basis of this project was to move ping pong ball as far as possible when given only one motor and two 12-volt batteries. The constraint condition was that ping pong ball cannot be placed over 10 centimeters and students should transfer energy in this following order. First, electric energy to wind energy, and then some kind of device will transfer the energy to ping pong ball. The project outline can be simplified in this order. Same motor and same batteries are given to every student, and the electric energy should transfer to wind energy, and then by some creative design, energy is transferred to ping pong ball. By doing this project, students can get more substantive understanding about energy transfer and energy maximization, efficiency maximization. I made the device in this process. By trial and error, I chose the best place type, and then, before making, we designed first. It seems very easy, but it took about 3 weeks. This is the device I made. The battery first transfer the electric energy to first blade, and then the wind made by the first blade makes second blade to rotate. Then the bar attached to the second blade hits the ping pong ball. Let's see how it works. Did you see? It is very fast, so I will see one more. The second creative design class project is graduation project. Every student majoring mechanical engineering in Yonsei University should do this graduation project. The goal of this project is to make a device that could issue a patent. This is one of the project results of this year. The device named Anti-Crash. It is composed of sensor, LED lamp, on-off switch, and stopper. Stopper works like this. The function of anti-crash is to stop the door when a person is behind the opening door. See, the sensor notices that a man is behind the opening door, then the anti-crash operates. There are many interesting projects in creative design classes as well as these two projects. Creative design classes help students not only to develop creativity but also to understand the principles of mechanical engineering. This is the reference list. If you want to know more about these things, go internet and search them.